Welcome back to our Database Design and Development unit for the final lesson in this series. In today's lesson, we will look at testing and evaluation. Our learning intentions are as follows. We'll learn how to test an SQL query. We'll also learn how to evaluate an SQL query in terms of whether it's fit for purpose and produces accurate output. As always, we have some success criteria, and for today's lesson it is as follows. We'll be able to test an SQL query. We'll be able to evaluate an SQL query in terms of its fitness for purpose and if it produces accurate output. When testing a query, the simplest way to check if that query works is to compare the expected output to the actual output of the query. Expected output is what we would expect the query to return, the results. We can look at this from the data in the table. This is easily done when we have a small data table. It's a little bit more difficult if we have a larger data table as an input. In our example, we will look to select the minimum years employed using an aggregate function from the employee table. We can see and analyse the data, and we can see what our expected output would be, and this would be the lowest number. In this case, the number 1 is highlighted. This is taken from the expression years employed within the aggregate function. This query is then run and we get our result, which is 1. On comparing these, we can see that they're the same. Our expected and actual outputs match. After looking at the testing stage of our database, where we look for results that are expected and results that are actual, and comparing those results, we then need to evaluate our solution. To do this properly, we need to go back to our end user requirements and our functional requirements, and looking at those, decide whether our solution meets those and can be described as fit for purpose. A significant part of that will be to determine whether those queries that we have created in this database solution perform correctly. We'll evaluate these queries on the correct identification, or whether it's a select, an update, an insert or a delete query in terms of the operation we're carrying out, the appropriate selection of the correct tables or entities or fields or entity attributes, the correct implementation of wildcards and aggregate functions, and the appropriate application of sorts on our data. We also must consider relevancy and, most importantly, the accuracy of our output. Let's look at our first evaluation example. An esports club runs weekly tournaments. The club uses 3 linked tables and a relational database to store details of players, tournaments and scores. And we can see the structure of our database in our example. Now, for that structured database, the following SQL statement has been written to add a new score to the score table. So we have insert into score, and we're inserting player ID and score, and we're inserting the values that we can see here in our example, P1815 and score 550. So we're inserting those values into the score table. Now, as we said previously, this SQL statement will add a new score into the score table. However, you may have noticed that the tournament ID data is missing. So the field to insert the tournament ID is missing from this. And this would cause the SQL statement to fail. Let's look at why this would cause it to fail. The tournament ID, as we can see, is part of a compound key, and as such is a primary key and cannot be left blank or null. It must contain some information. We can see from the structure of the database that player ID is the primary key in the player table, tournament ID is the primary key in the tournament table, and both are foreign keys, but also primary keys in the score table. They combine to make a primary key or a compound key, and therefore it cannot be left blank or ignored in this statement. In this case, we would come to the conclusion that this SQL statement is not fit for purpose. In our second evaluation example, a swim club uses a database to store details of swimmers and their times in a 50 metre swim. A sample of the swimmer table is shown below. Again, we have a swimmer table. We have 4 entity attributes: swimmer number, swimmer, squad and time, and the corresponding data. Now, the head coach would like to produce a report displaying the slowest and fastest times from any squad with a 1 in their name, as shown below. So we can see the results of what we are looking for out there. Now, in order to get this output, we have created this SQL statement and tested it, but realised that our actual output didn't match the expected output that we had suggested. Our SQL statement states select squad min time as slowest time, max time as fastest time from swimmer where squad like 1. We have identified that there are 3 errors in this SQL statement, and as such, when evaluating it, we would decide that this is not fit for purpose. But let's look at where this has gone wrong. So there are 3 issues here. The first issue is the min and max aggregate functions are the wrong way round, and as such the min aggregate function would find the fastest time because it's the minimum amount of time to swim that 50 metres, and the max aggregate function would find the slowest time because it's the longest time to swim that 50 metres. Our second issue would indicate that we have no wildcard operators on either side of the number 1 in our where clause. So that should read where squad like wildcard 1 wildcard to identify if a 1 is somewhere within that squad name. The final issue is that we have not used a group by clause at all. Earlier in our lessons we spoke about non-aggregate expressions and aggregate expressions. So an aggregate expression would be our aggregate functions min and max, and in this case in our select statement we have squad there also, which is a non-aggregate expression within this SQL statement, and as such all non-aggregate expressions, when you have a mixture of these, must be included in a group by clause. So if you have 1 or multiple non-aggregate expressions, these must be included in a group by clause. So in this case we should have said group by squad. After evaluating this statement, we would decide that this SQL statement or query is not fit for purpose. This concludes our series of lessons on database design and development. I hope you found these lessons useful. For more content, please like and subscribe.